So our next speaker is from Citrix, talking about virtual desktop storage strategies. Give us another look at this. So I'll turn it over to Steve.
Thank you very much. How's everybody doing today? Yeah? Good event so far? All right. So today I'm going to talk about various storage strategies you can employ with Citrix Zen Desktop, which is our virtual desktop offering. I'm not going to get too far into how to tune this or that on ZFS to work with this technology. Richard Elling is going to be coming up after this, and he's going to be doing a lot of that anyway, so I didn't feel it was good to be redundant. So I'm going to start talking about what virtual desktops are from a Citrix perspective. I think we could probably all agree. Actually, let me ask it right now. From your perspective, when you think virtual desktop from an industry definition, you think Windows 7 on some hypervisor, right? Is that what people kind of think of? Okay. So that's one way we do virtual desktops, but we do virtual desktops a lot of other ways, so we'll talk about the differences in that. We'll talk normal storage stuff. We'll talk about how Zen Desktop by itself does storage. And then we'll talk about some alternative approaches to storage that we can utilize with the product. And I'll talk about how they can apply to different back-end storage infrastructures as we go. So, there's kind of this thought of one size fits all. When you look at the competitive offerings for virtual desktop, they really are just that. They really are a hypervisor running a desktop operating system, and then you farm those out using whatever remote display protocol you like. That's a one size fits all solution, and it doesn't always fit for the types of users that you're trying to deploy, and your ROI can go through the roof as a result. You may or may not get the desired value out of that type of solution. So when we talk about all of our users, we've got a lot of different use cases. We've got everybody from a mobile worker to a task-based worker. That task-based worker may be in 3 apps all day long. Their work patterns are very consistent. They don't deviate from those. But giving them a full hypervisor-based desktop may not get you the ROI you want, or may not accomplish your goals for storage or where you want to consume CPU or memory resources. So we've got a lot of different ways of dealing with these different types of use cases and user elements. So what we have here is 4 different ways that we can present a virtual desktop to a user. Starting here over on the left side where we've got hosted shared, that's what Citrix has been doing for the last 20 years. Okay? We do session-based virtualization in that case, and we're going to take a Windows Server platform, we're going to carve it up with sessions, and we're going to give a user a desktop, but it's just going to be a representation of a desktop on one system. The relationship will be many users to one system, okay? And we'll chop it up that way. Now that works great in that task-based worker type of design, or maybe call centers, or possibly factory workers, where their work patterns are expected. They're not deviating from their work patterns every day. They're going into 3 apps all day long. Those apps are very well known, and you know how they're going to perform. You will absolutely, positively get the best ROI deploying in this method. We've been doing it for 20 years. It works really well, but it doesn't apply to everybody. When you have those use cases where your workers do deviate in their work patterns, or they need more customization, more personalization, things like that, then we can move over here to this hosted VDI model. That is the traditional model that basically the industry considers VDI, right? It is a desktop operating system running on top of a hypervisor. In that case, the relationship there is one-to-one. You've got one user that is going to one desktop OS. Okay, and when you start talking about plugging in USB devices, maybe it be a phone or some thumb drive or something, in a client and remoting that into the virtual desktop, that's very easy to do because of that one-to-one relationship. When you start talking one-to-many, then those customizations and those personalizations become a little bit more messy. So continuing over here, another technology that we have at Citrix is known as provisioning server. So provisioning server allows us to stream an operating system across Ethernet to a target. Now, we can use this for Windows, we can use this for Linux, 32 or 64-bit, physical machines, virtual machines. We don't care. So the concept here is that a virtual desktop may be the desktop that's sitting on that user's desk or under that user's desk, but we're managing it differently. We're not installing a local image that, when you roll from XP to 7, you have to go out to somebody's desk and physically run the installer. We don't want to manage that way anymore. We want to manage differently. With Provisioning Server, we can stream an OS down to that desktop and manage it differently. We can stream an OS to a workstation class Blade or a Blade PC in the data center and give a user, again, one-to-one relationship, one user, in that case to one Blade or workstation class PC, something like that, in the data center. There's that relationship, but we're managing it dynamically. We're managing it differently. And we're giving them specific end user resources. We can pass through GPUs, right? Let's say you have a CAD-CAM application and you want to remote it to India. You can have workstation class Blades in the data center, have a GPU in each one, and then the app can use that GPU, and we can use that GPU to get those bits across the wire effectively, okay? So in that case, you are taking a hit because it's going to be more expensive, right? You've got workstation class Blades, one for every user in the data center, but you don't have a locally installed OS. You can treat them dynamically. We'll talk more about PVS and how it works later, but suffice it to say that we can take a common image and we can stream it to multiple targets simultaneously and dynamically change that on the fly, okay? If I want to send out an XP image, I can do that. If I want to change what's running on a specific box to Win7, I can dynamically reboot that box, change up the image, and say, okay, now you run Win7. And I can do those types of things and manage it from the data center. Local VM over here, this is what was brought up in the last session, Zen Client. Zen Client is a type 1 hypervisor that runs on a desktop or laptop form factor. So basically what we did is we took our Zen server hypervisor technology, we stuffed it into a laptop and said, now you're going to learn about sleep states and wireless networking and in-your-face graphics. And that's in essence what Zen Client is. Type 1 hypervisor, you install it bare metal on a laptop or desktop device, and then we have back-end technology that can provision virtual machines on top of that and then manage that experience. We can back up the deltas back into the data center. We can do kind of tricky manipulation stuff. We can combine it with streamed VHD. So maybe you have a requirement where somebody needs a workload just when they walk in the office. But when they leave the office, you don't want them to take that with. You don't want them to take it with them. So in that case, we can, they walk into the office, they set their Zen client on their desk, plug it into Ethernet, and then we can stream an image down while they're in the office. And when they leave, it's not there anymore. So we could do those types of tricks, okay? So the real point is a virtual desktop to us does not necessarily equate to a desktop running on a hypervisor. We have a lot of ways of provisioning desktops, and at the end of the day, we want to manage it very differently. So I already mentioned the top point and the second point. We have lots of configuration options. Some of our competitors bill us as being very complex. The fact of the matter is you don't have to deploy all the technologies that we can do. You need to deploy the technologies that you need to use for a specific use case or work pattern or user type. Okay? So you need to identify who your users are, and you need to say, okay, I'm going to deploy this way for this reason. These are the requirements, and you can consciously decide where you want to consume CPU and memory resources. Do you want to consume them on the Zen app server somewhere in your data center? Do you want to consume them on the desktop on the hypervisor in your data center? Do you want to consume them on the client device? We can push apps all three different places, and you guys can consciously make that decision and then consciously determine what ROI you need out of a certain situation. And then we're hypervisor agnostic. When you are using desktop OSs on top of a hypervisor, we prefer Zen server for a couple of reasons, but obviously you can also run on vSphere or Hyper-V. So, really it's up to the customer to determine what they want to run it on. Excuse me. So, status quo of storage. When we start talking about Zen desktop storage, we don't know if we're running on a hypervisor. We don't know, from this discussion whether or not we're streaming physical machines, things like that. We'll talk about streaming physical machines. In this case, we are talking hypervisor, right? The hypervisors that are bundled with Zen Desktop are Zen Server from us, and we also bundle with Hyper-V. About 50% of deployments of Zen Desktop now are going on top of Zen Server. So when you talk Zen Server, you've got NAS-based storage, block-based storage with fiber iSCSI, and then a lot of people say, okay, well, when you're deploying to block-level storage, what file system do you use? Well, we don't. Okay, when architecting Zen Server, we wanted to come up with a way of getting multi-tenant storage without having a messy file system. So way back when we came out with it, we deployed it with an LVM solution. Basically, we present block level disk to the hypervisor or the hypervisor pool, and we lay down LVM information. And then when you request to create a virtual disk, we will create a logical volume on that LUN and then present that directly to the VM. Now, in later versions of Zen Server, starting at about Zen Server 5 or so, we came up with this technology known as LVHD. So we basically coupled together Logical Volume Manager and VHD to give us the best of both worlds. So Logical Volume Manager gives us the multi-tenancy aspects and the raw block aspects of block-level storage, but then we lay down some some VHD metadata, which allows us to treat that logical volume as if it were a VHD file. And we can do tricky things with that. We can chain it and do snapshots and things like that with it, and that's where we get some of the more advanced functionality of Zen Server from there. But the fact of the matter is, we don't use a file system. So, first question, people coming from VMware to Zen Server say, well, where's my VMDK file? If it's on block storage, it doesn't exist. If it's on file level storage, we just use VHD files and go about our merry business, just straight VHD. Okay? So, now, moving on forward, going into provisioning services a little further. When scaling really big, okay, image management is key. Provisioning server offers you the ability of having a single image that can be provisioned to literally thousands of clients simultaneously. Okay? The concept is we're going to decouple the workload from the compute node, or that OS and app stack that you install on a server. We're going to decouple that from the server itself. And that allows us to dynamically provision Windows or Linux 32 or 64-bit to physical or virtual machines. So, concept is you walk into a data center. Today, typically, you could point at a machine. That's a web server, that's an app server, that's a database server, et cetera, by virtue of you having installed an OS and app stack on that machine. What we're going to do with provisioning server is, in essence, break that. We're going to go through kind of a type process. We're going to take that image that you've installed on the disk, and we're going to push it into a VHD file sitting somewhere behind provisioning server. Now, provisioning server doesn't have any requirements on what you put behind there, so technically you could put a NAS or SAN or something else behind there. The fact of the matter is, we get a lot of benefit from read cache. So to get the best bang for your buck, you're going to want it on NTFS behind provisioning server or SMB2, because SMB2 added file level caching. So one of those two will get you the best bang for the buck. Okay? So I've got these images created here. The next, you set these machines to boot Pixie, and you can potentially remove the hard drives out of them. The next time they boot, we're going to stream that workload across the wire. So in essence, what happens, the machine boots, goes out to DHCP, gets an IP address. DHCP also gives them some Pixie information, goes out and talks to provisioning server, says, hey, I'm here. What do you want me to run? Okay? Oh, you're supposed to run this. Provisioning server looks up in a database, says, you're supposed to run this, and starts streaming those bits across the wire. Now, this isn't an imaging process. Okay? This is actually streaming the requested bits. You can kind of sort of think of it like iSCSI, right? Disk requests are going to go across Ethernet and be fulfilled by provisioning server. All right? So that's all fine and good. We've decoupled that workload from the compute node, right? But now what I want to do, when I create this, we call it a vDisk. When I create that vDisk, it's in a mode called private image mode. In private image mode, we label that as read-write. So any bits that we write into that vDisk are actually written into the VHD file. We can flip that to what we call standard image mode. When we go from private to standard, we changed it to be a read-only file. At that point, I can use that one file to provision many targets. Okay? So this file right here can be used to provision, in this case, say all 9 of those servers, right? Writes have to go somewhere. That file is read-only. You have your choice of where writes go. You can send them back to provisioning server, in which case you're going to have a little bit of a performance hit because it's got to go back across the wire. You can use local RAM, and you can use local hard disk. Okay? Now, in the terms of a virtual machine on a hypervisor, that local hard disk is going to equate to hypervisor-based storage. Now, that write file, that delta file, is transient. Okay? When you reboot that machine, we're going to get rid of that write cache, and we're going to start fresh. So that data, that write cache data, doesn't need to be RAID protected, doesn't need to be backed up, doesn't need to be on expensive storage. It just needs to be there. Characteristics of it are 95% write. And Richard and I did some work with this and some analysis of this a while back, and we found that 95% of the I/O was write. We found that over 40% of those I/Os were misaligned, even in Win 7. So, we find that these characteristics are very conducive to using ZFS behind the scenes for that write cache. We found that the data was not dedupable. Okay? We turned on dedupe and didn't get much value at all. Compression, though, was fantastic. So optimizing it to a 4K block, inline compression, we were able to get 100 users, write caches for 100 users. I think we set the write cache size for each target to 3 gigs. We had 100 desktops on one physical box, and we had the write caches all going to an Exenta Store system with 2 32 gig drives in it. Okay? We were able to, with inline compression, we were able to get a footprint while all 100 sessions were going of less than 4 gigs. Okay? Very good, very robust, very low latent storage for that type of entity. Now, if you think about that, the read stream is coming across Ethernet. The write stream is going a different direction down into whatever storage the hypervisor has been told to use. In this case, we were using NFS. You could use iSCSI or Fibre Channel as well. There are some differences, which we'll talk about later, that may make you want to go to NFS for this type of activity. But suffice it to say that we are going to separate that read stream. Now, when we talk about scaling, in the lab, we've been able to take one very beefy server, take a single image on there, and stream 4,000 targets from it. Okay? Now, provisioning server can scale in an HA model up to 8 nodes wide. So do the math, right? 8 nodes at 4,000 each, that's a lot of targets you can go. So very robust, very easy image management. You want to upgrade from XP to 7, you can say, okay, now all you 4,000 targets, you're now going to use this image. And boom, you reboot them, and they're now on the new image. Okay? Lots of cool things to do with that. So, as I mentioned, we're going to fundamentally separate read and write. Read is going to go across Ethernet. Write is going to go across hypervisor technology, or it may just stay local if it's a physical machine, something like that. If you go to RAM, there's no out-of-the-box write I/O, right? It all stays in the box. If you go local hard disk, there's no out-of-the-box I/O. It all stays in the box. And then, except for hypervisor-based machines, then you've got that stream going to wherever the hypervisor says to go. When you're talking about PVS write caches, there is additional latency. That write is going to go back across the wire to the provisioning server, and there will be a file on the provisioning server. So that could be a hit. So keep that in mind. Very large scaling, 95% I/O load, write operations. And then this is hypervisor agnostic again. You can run this on any hypervisor you want. Okay? So very cool way of scaling really big. Now, something new to Zen Desktop as of Zen Desktop 5 is something that we call machine creation services. in essence, we get the benefits that we get from provisioning server, but we take the network out of it. Okay? So we get that ability to have a master image provisioning multiple virtual machines in this case, right? The machine creation services is specifically for hypervisor-based desktops. And it's going to do that with storage technology, not do that pixie boot process that I just described for provisioning services. Okay? Got a couple services that are going to keep track of this. I won't go into those right now. They run on our broker. So we're going to base it on a master image. We can do multiple modes. We can do a shared mode, which is basically more of a pooled mode. The transient write cache. That write cache will be deleted during the reboot process, and it will start fresh every single time. Golden image boot every single time will reduce your help desk calls. If somebody has a problem, they reboot their box, they're back to golden image every single time. You can go private mode, okay, and that will give you persistent images. You go back to more of a traditional model at that case. There are ways of very easily updating that image, but some of those caches that or deltas that you've got associated with that are going to break at that point. We're going to have each VM have a differencing disk and an identity disk, and I'll go more into that here in this next slide. Hypervisor agnostic. Your best experience is going to be on NFS though, okay? The reason for that is because you look across the storage array possibilities. NFS is the easiest to deploy, and you're not going to get legacy SCSI problems. Now with Nexenta Store, it's not a problem, right? You're not going to run into the 512 LUN max on a unit where a NetApp at 512 LUNs will fall over if you try to do another one. You won't find that with Nexenta Store. You get thin provisioning with Nexenta Store. So realistically, you could use block level storage for this. The problem though is management. When you look at how that block level storage is presented to the hypervisor, we see it as a fixed size, as something that we can exhaust very, very quickly, even if we're using thin provisioning, because the thin provisioning characteristics don't necessarily come through the hypervisor interface. So if you're using block level storage, you just need to understand that you're not going to see a true representation in the hypervisor management console. NFS, very easy to deploy, very easy to scale wide. You don't have any of those historic limitations. So with machine creation services, we're going to have a master VM that's tied to a master image. Now, we're going to use that master image, and we're going to boot multiple virtual machines from it, just like we did with provisioning server. We're going to have Delta files down here, but we're also going to have this identity disk, okay? This red disk down here. That identity disk is going to persist with that machine for the life cycle of that VM. That Delta disk, however, is going to be potentially recreated on every reboot, okay?